Welcome back, Math 7. Today we are almost finishing up our Unit 9 or Chapter 9, Probability. As you may notice, I am using a little bit of different method. I used to use this kind of screen whenever I help students with who has a question. And as you may know, I used to use document camera and then write down my writing on a blank pieces of paper or booklet. But let's see how this go. Sometime it is more clear to see the screen, right? So it is a little bit of experiment from my side. Today we are going to go through application of independence event, and then some of you guys already know about this concept, but consider it a little bit of reinforcement. It is available on page 15, and we're going to do two examples, so it's going to be a relatively short lesson. And when it comes to homework question, there's about 3-4 questions for the homework problem too. So as you may notice, independent event. This is the one where you need to consider that, how can I say, one event never affect the other event. What I mean by that is, if I have Looney that has head and tail possibility, if I throw Looney, and let's say I have more possibility of having head, that doesn't mean you have a preference for another event. For example, if I have six-sided dice, die in this case, if it's single, then you will probably predict not the even number just because the head is showing up here. It will be completely random. So like what I mentioned, one event will never affect the other event. That's what I want to point it out to you. And that is one of those main part. So some of the question, we're going to go backward. You have some kind of tree diagram or tables given, or some of the question, we are not going to use table or tree diagram so that we can go advanced type of question. We have tree diagrams given. As you may notice, from the first side over here, we have first branches or event number one. And when it comes to second, we have several other branches. Example number two. So the first part of the problem was asking, describe or draw a spinner and a die that would produce the possible outcome. So first event, as you may notice, the question is saying that one of the event is spinner. Another event is a dice. So you know the fact that the first branch that we highlighted over here is in fact talk about this spinner. And when it comes to dice with the number, it is in fact described by this number two event, which is the red column over here. So that means if I draw a die, I'm gonna do both because some people prefer drawing, some people prefer answering. So A. When it comes to spinner, it seems like I have A, B, C, C. A lot of people try to draw. Since it's A, B, C, I'm gonna just produce this by 1, 2, and 3, and I'm gonna go put A and B and C so that we cover everything. Sadly, that's not the correct way of doing it because, as you may notice, can you see that there's A and a separate A? That's a fancy way of saying I have 1, 2, 3, 4, 5 different sectors. So this is more like it. A, A, B, C, C. Something like that. As you may notice, I created a spinner that has 5 different sections. And know the fact that even though it look alike A and A, you're right. However, we have 5 different possibilities. That means A and A is another independent event from this sector to another sector. This is spinner. And when it comes to dice, dice with 4 sides, which is kind of hard to draw. but this will be diced with the foresight. As you may see, I have front, left, and right as a pyramid, and then at the bottom. And you can put the number in. Like, for example, this is my 1, that's my 2, behind is my 3, and bottom will be my 4. Something like that. Although it's kind of hard to visualize, think about pyramid with the bottom part as a triangle. So, as an explanation to describe this, I like to say event 1 involves a spinner with 5 sectors A, B, C, and C. Event 2 involves a die with 4 sides 1, 2, 3, and 4. And ladies and gentlemen, this statement summarizes what we draw over there. So first part A is done. Good to go. Now second part. What is the probability of having B and 2? Now I know that I have all of the possibilities given. Imagine we don't have this tree diagram. Then we need to find our probability of B2. Sorry. Oh yeah, it is B2. Here's what you do. As you may notice, we just figure out our, gonna use blue. We just figure out our spinner over here. We have 1, 2, 3, 4, 5 different sectors. So that means I have 5 different possibility. On the other hand, when it comes to dice, die is at 1, 2, 3 and the bottom of 4. So I have 4 possibility. Last time I explained to you how we can find the total probability or total outcome by simply multiplying the total possibility together. Then 5 times 4 provides you our answer 20. And ladies and gentlemen, that should relate to our total possibility that you can find from my tree diagram. And you can double check. I have 1, 2, 3, 4, 1, 2, 3, 4. So 4, 8, 12, 16, and 20. As you may notice, this is a little bit of shortcut how you can find the probability without actually producing a table or tree diagram, which is sample space. So probability of having B and 2. First of all, you know that B has only one possibility over here, and 2, there's only one possibility. So in the end, having probability of B over 2 is just one desirable outcome out of 20. So this is your fraction of probability. 1 out of 20, you can multiply everything by 5, ladies and gentlemen. And if you do multiply by 5, then what you will have is instead of 1 on the numerator, there will be 5. Instead of denominator 20, it will be 100, and thus it will be 0.05. And if you want to point it out as a percentage, you multiply by 100 or move the decimal by 2, then you have 5% chance. Now what's next? C. What is the probability of getting A and A3? As you may notice, now things are a little tricky because when it comes to A, I have double the possibility. So A and 2, A and 3. You may notice that I can have a possibility of having this A on the left and 3 combination, or the one on the right there you go. It's ugly, sorry about that. Again, like I said, A and 3 possibility from the left, A and 3 possibility from the right. So There are two desirable outcomes this time, unlike the previous situation. So I like to say C and P, probability of having A comma 3. My desirable outcome is 2 divided by 20, which is 1 over 10. And 1 over 10, ladies and gentlemen, is equivalent at 0.10. If you multiply by 100 to bring it up to percentage, then it will turn out to be 10%. Or bring the decimal place twice to the right. That is what you will do. So probability for C is done. Now, one of the last part, what is the probability of getting C, a number less than 4? Now things are a little bit more ultimate challenge over here because, as you may notice, C is two different sector like previous situation and number less than 4. So it is good idea to figure out possibility that satisfy this situation. So if you don't mind, I'm going to quickly go to a blank pieces of paper and then I'm going to do B over here. And probability was having C and any number that was less than, I forgot, less than 4. So 1, 2, or 3 situation. If I don't have any of a tree diagram, then it's a good idea to predict some. What I mean by that is there is P, C, and 1. Sorry, we don't have to put P. C and 1, that's one combination. C and 2, and C and 3. However, you guys may notice that I have second C. So C and 1 will be another possibility. C and 2, and C and 3. So we have total 6 possibility. So that's a fancy way of saying I have 6 over 20, which is I can divide everything by 2 to get a simplified number. Then 6 divided by 2 is 3, 20 divided by 2 is 10, and that is equivalent as 0.30, which ultimately turning into 30%. That's how you solve the problem, folks, when it comes to any of a real life situation. All right, now we are at the last question, and this is our last part of today. And to specifically explain this example, I gotta make sure that I forgot to give a diagram for this question. So I'm going to show you. A card is chosen at random and a die labeled 1 to 6 is rolled. So as you may notice, we have two events going on like the previous situation. A card from a deck of card, and the deck of card in the diagram was it has 1, 2, 3, 4, and 5. I believe it was clover, something like that. It's not the entire 52 deck of card, but you got the idea. And a dice that has 1 to 6, or 6-sided dice. So we have event number 1 and event number 2. So we have two of those. I know that A is asking about the table. I'm not going to do the A because this is a part where imagine, is there any way that we can find out the probability of what we want to find without having a table? And it is possible. And this is how I'm going to do. We're going to do rather estimation and educative assumption in here. First thing first, event number 1, a card has 1, 2, 3, 4, and 5. That means I have 5 entire possibilities. So when we try to find out total possibility, you need to understand that one of the maximum event, which was 5, and the second one have a 6-sided dice, so 5 times 6 is what we need to do. And simply that's the one that you should do, which is 30 total outcomes. And this is the skill that I'm going a little bit beyond Math 7. However, if that helps you eventually, especially when you solve multiple choice question and so on, feel free. I'm not going to stop you. So we know that 5 times 6 give you 30 total outcome. So that means this total outcome, when you do a probability calculation, that should serve you as a denominator. Now, then without further ado, let's go with this B situation. B, what is the probability of getting only 1/6? So in this case, we are talking about having die number that is 6 instead of having any others. So, because first of all, as you may notice, I don't have any of a 6 in this card situation. So what you need to do now is predict some of the outcome that fit to this situation, which is if I pick one number for the card and then 6, 2, 6, oops, 3, 6, 4, 6, 5, 6. And oops, sorry, I just realized I did C over here. Probability getting up at least 1/6. Never mind. Then I'm just gonna change it. Sorry, folks. There you go. Dice number 6 and whatever the other number. That's probably what you can do as a best. And in that situation, you find out 1, 2, 3, 4, 5 different scenarios. So it's 5 over 20, which in the end, you guys know that I can simplify this guy by divided by 5. There you go. If I divide it by 5, then you will have 1 over 4. And as you may notice, ladies and gentlemen, 1 over 4 is a common fraction. It's 0.25. You guys remember hearing about the term 25 second. I mean, sorry, 25, so that's a quarter. And if I multiply by 100, 25% possibility. All right. Since I accidentally and unintentionally did C, which is having at least 1/6 in this situation, and now what we need to do is we need to go back to B, which is having a probability only 1/6. Long story short, I'm gonna tell you about this probability. It is zero. Zero possibility. Or sometimes we call it impossible event. The reason that is 0% possibility is because if you think about it, we are picking two objects, which is a card and a dice. And probability of getting only 1/6 is impossible because we are picking two. So having only one type is impossible. That was way simpler than I thought. So now we did B, we also did C. Now let's go through the other one. Oof, these can be tricky. What is a situation where we can have two numbers having the sum of 10? Now things are a little tricky because now we need to think about adding situation. Is there any way we can have sum of 6? Yes, we can, but in order to do that, we need to find out our condition. P having sum of sum that makes 10. Before we list our fraction, it is important to go through some example. 4 and 6, that work. and 5 and 5. That also work. Is there any 3 and 7? Unfortunately, that's impossible because 3, yes, in the card deck of card, it works. But when it comes to dice, 6 is a maximum. So 6 plus 3, that's the only case that you can have, which is 9 in that situation. If I pick 1, then other part I need 9, which is impossible. If I pick 2, then I need 8 from the dice, which is impossible. So 3, 7, impossible. The only thing that is possible is 4 and 6, 5 and 5. So in this situation, it's tricky possibility, as you may notice. However, once you figure that out, you know that 2 over 20 is what you have. Is that the most simplified number? No, it's not. Divided by 2, then 1 over 10, which is 0.10. If you multiply by 100, you will notice that that's 10% possibility. And our very last portion, E, which was what is the probability of two numbers having a sum of 10 or more? Okay, so if I have to deal with probability, sum that makes bigger or equal to 10 in that situation. Like I mentioned and before, we need to predict what kind of outcome that satisfies that situation. So first thing, we already know that it overlaps with D. So 4 comma 6 is one possibility. 5 comma 5. And is there any more? Yes, we do have 5 comma 6, which is 3. I'm sorry, 11. 5 plus 6 is 11. So as total, we have 11 or 12 possibility. Fortunately, at this point, you know that this is already simplified. However, when you try to make it into percentage, you need to make anything that have 10, 100, 1,000 as a denominator. So what I'm going to do is I am going to multiply everything by 5. Then what I will have in this situation, ladies and gentlemen, is 11 times 5 is 55, right? 20 times 5 is 100. So, long story short, we have 0.55 as your decimal probability, which means if I multiply by 100 from there or move the decimal place 2 to the right, then I have simply 55%. And that is how you do these complex type of, how can I say, probability question with or without sample space. And this is advanced question, ladies and gentlemen. You don't have to use my method that I suggest, which is mental math method. If it works, then that's good. If it doesn't, I strongly suggest, even though I didn't do in this specific example, I made a lot of sample space and table before, I highly recommend you doing that process first. Your homework question is quite simple, like I mentioned over here. Oh, sorry, it wasn't 4 question, it was 5 question. So I want you to give it a shot. Page 181 to 182, number 3, 4, 6, 7, and 9. I want you to give it a shot. If it overlap with some other assignment question, then just do something that I didn't assign.